Chapter 11, Force and Pressure. In this chapter, we will understand about force, its various types, and the effects force can cause. We will also see the relation of pressure with force. Whenever an object is at rest, we need to apply force to bring it in motion. Or if the object is moving, then we have to apply force to stop that object. Simply to define force, we can say it is the push or pull of an object. Some examples here, like pushing a table is needing force. If we pull the table towards us, then also we have to apply some force. The boy kicking the ball, opening of the drawer, the man pushing the girl on the swing, the earth revolving around the sun are all examples where some sort of force has been executed. SI unit of force is Newton. Do you know whether force is a scalar or vector quantity? As force is dependent both on direction and magnitude, hence we can say force is a vector quantity. For example, the truck here is receiving force in the same direction, 60 Newton force and 30 Newton force to the right side. So motion will also be to the right, and as it is a vector quantity, so the magnitude here will be additive and it will become 90 Newton force which this vehicle will be experiencing, and it will be moving to the right side. In the next example, we can see that the object is receiving force from both directions. The object is moving towards the left with a force of 10 Newton, and there is also a force applied from the right side of about 30 Newton. The resultant force that the object will experience is 20 Newton, and it will move to the right as more force is being in this particular direction. Here are some more examples how different forces acting in a body, and we can find the resultant force. In the first case, we see 2 Newton force is acting on both sides. So the resultant force is 0. If in both directions same force act, then there will be no net force acting on the body, and the body will be at rest. In the second example, we can see 2 Newton and 3 Newton force is acting in the same direction, that is the right side. So here the object will experience the net force, that is the resultant force of 5 Newton, and it will move in the right side. In the third example, we can see an object, it is receiving 3 Newton force towards the right side, and 2 Newton force is being exerted from the left side. So the resultant force is only 1 Newton as the directions are just opposite. Thus we see the size and direction of the resultant force determines how much, if a body is moving, then how much it will experience the net force. Now let us see the effects of force. Force brings an object to motion if it is at rest. The boy cycling, the car or the truck that is moving stops on applying brakes, that is a type of force. The footballer kicking the football. Here we see the state of motion of the object is changing when force is applied. Force also changes the direction of the moving object. The badminton here is being played and we see the cock continuously changes its direction when force is applied in opposite direction. The boy cycling experiences the change in direction and state of motion when there is an obstacle in between. The shape and size of an object may also change on application of force. For example, sponge ball on compressing or making dough, it can also be made into different shapes. There are different kinds of forces: contact force and non-contact force. The contact force is that type of force in which two objects are in contact. There is a physical contact between two objects where force is being applied. Non-contact force, there is no direct or there is no physical relation, contact between the two objects. Some examples: here we have categorized contact and non-contact forces into different forces. Contact force is classified into muscular force, mechanical force, frictional force. Non-contact force is classified into gravitational force, electrostatic force, magnetic force and nuclear force. Now let us see each kind of force with its example. Muscular force. In this case, the muscles are exerting the force. The horse running is using its muscle. The boy cycling is using his muscle for motion of the cycle. Next contact force is mechanical force. In mechanical force, we can see the object experiences the force due to various mechanical activities such as movement of the wheel, the movement of the cycle chain. These are all examples of mechanical force. This force are especially there in the machines. Next important category is the frictional force. Friction is basically the opposing force which acts in the opposite direction to the applied force. We experience friction while running, while moving an object from one place to another. A ball, when rolled on ground, automatically stops after some time due to the frictional force, that is the opposing force of the ground. Now let us see the different types of non-contact force. First in this category is electrostatic force. Electrostatic force of attraction occurs between oppositely charged particles and repulsion is between similarly charged particles. This type of force exists when opposite charges are attained by the two surfaces. They are not in direct contact, but when they are brought near, there is a force acting between. Next is the gravitational force. It is the force which is exerted by the earth which pulls the object towards itself. We can see the movement of moon around the earth is due to the gravitational force of the earth. The falling of an apple from the tree is also an example of gravitational force. Next example of the non-contact force is magnetic force. Magnetic force occurs between a magnet and magnetic materials, those materials which get attracted towards magnet like steel, iron, nickel, cobalt. There is no direct contact, but due to each other's effect they get attracted. The fourth category in this is nuclear force. It is the attractive force that acts between nuclear particles that are close together, such as protons and neutrons in the nucleus. The strong force binds the nucleus. Now let us see how force is related to pressure. Pressure is the amount of force that is acting on a unit area of an object. So we can formalize it as pressure is equal to force upon area. The SI unit of pressure. Pressure is defined as force per unit. So we can write it as pressure. Its unit is Pascal, that is denoted by PA, which will be equal to force whose SI unit is Newton upon area whose SI unit is meter square. Thus, the SI unit of pressure is Pascal, which is equal to Newton meter square inverse. Now, as we can see that pressure is inversely proportional to area. So, if we decrease the area, the pressure experienced will be greater. Whereas, if the area is large on the same force acting on a substance, on an object, then the pressure it will exert will be low. Here we have two objects on which same force has been applied. One object is having very small area, whereas the other is having large area. That is the sharp knife with smaller area and dull knife with large area. So a sharp knife will exert high pressure and hence it will produce good cutting, whereas a dull knife will exert low pressure and the cutting will not be good. Pressure also decreases with increase in area of contact. Now we can see the feet of the camel. They are usually broad, and here we are using the skiers to ski in the snow. Both of these help us to understand how increase in area of contact will decrease pressure. So a camel will easily walk on sand and a skier will easily ski on snow. Pressure in fluids is depending upon the depth of water. The pressure in fluids will increase with the height of the liquid. For example, if we are having a spouting can filled with water, it is having 3 nozzles at different heights. When the spouting can is filled with water, we see that the lowest nozzle. From there the water is coming out with high pressure. So we can conclude that the pressure will be more at great depth. Now, water also exerts equal pressure in all directions, but if it is at same depth, then only. If the depth is not same, then the pressure exerted will always be different. A sea diver faces large pressure when it is deep under the sea. So they wear special suits to prevent themselves from experiencing the high pressure and being crushed. Now let us see what atmospheric pressure is. Atmospheric pressure is the pressure of an object which it feels due to the weight of the air above it. Some applications of atmospheric pressure. We can see while we suck from the straw juice or any liquid, it easily rises in the straw. It is because the pressure will decrease in the straw as we suck the air as compared to the atmospheric pressure, and the atmospheric pressure on the liquid will be more. This will lead the liquid to be pushed upward in the straw. In the second example, we can see how the syringe works. When the piston of the syringe is pulled due to low pressure in the cylinder of the syringe, the liquid enters in the syringe as the liquid is facing atmospheric pressure which is higher than that in the syringe. We see rubber suckers, they get easily attached on the wall. This is because when they are forced to attach on the wall, air is being forced out and now atmospheric pressure is acting on them. Due to the difference in pressure, they stick to the wall. Next example in this case is vacuum cleaner. It also works on the same principle. The vacuum cleaner is having a fan which rotates when the vacuum cleaner is working, and the pipe there is created partial vacuum. Due to less pressure in the pipe as compared to the outside atmospheric pressure, the dust and the nearby air will rush into the mouth of the vacuum cleaner. So we can easily summarize how pressure is related to our daily activities. So that's all for this chapter. Thank you.